In this example, we are going to construct a confidence interval to estimate a population proportion. So in a 2020 Gallup poll, 1,035 U.S. adults were asked if they believe marijuana use should be legal. 704 answered yes. Construct a 95% confidence interval estimate of the proportion of U.S. adults who believe marijuana use should be legal. Express your final answer in decimals and round to 3 decimal places. Note that we are looking for trying to estimate a population proportion here, and our population is just U.S. adults, right? And it's the proportion who believe marijuana use should be legal. So up here we have a sample. The sample is size 1,035, and it looks like 704 said marijuana should be legal. So that is going to give us the sample proportion. X over N, we could say that's our successes over the sample size. So the question is, well, I always calculate this just out of curiosity whenever I start one of these questions. Punching that into the calculator, that's about 68% said that they thought marijuana use should be legal. So that's pretty high, right? 68%. And this is actually what we call the point estimate, right? For the population proportion. Okay, so the first thing I'm going to do, and I'm just going to do this verbally, is before I jump into the formulas for the confidence interval, I just want to quickly do sort of a verbal check of the requirements and make sure that they're met. So first of all, this was a Gallup poll, so I can assume this is a random sample. I can check that the conditions are met, that NP is greater than 10, and NQ is also greater than or equal to 10. That's essentially just saying that I have, 704 people answered yes. That would be equal to NP, and that means 331 answered no, and that would be NQ. So we just have to make sure those are both greater than 10 so that we can assume the sampling distribution of the sample proportions is approximately normal. Okay, since the requirements are met, we can use the 95% confidence interval formula. Okay, so I have my sample proportion, my multiplier times my standard error here. So I'm just filling in the numbers. Okay, and normally I would just punch this into my calculator to try to avoid any sort of issues with rounding. If you can rewrite the second part to make it a little bit easier to punch into your calculator, it is equivalent to the square root of 704 times 331. Okay, so it is equivalent to that. So I would pop that into my calculator, and that gives me, okay, and if I round to 3 decimal places, my confidence interval estimate is, so this would be my final answer. And we should always make sure to interpret our confidence interval. So here I have one way to interpret it. So we are 95% confident that the proportion of U.S. adults who believe marijuana use should be legal is between 65.1% and 70.9%. Before finishing the video, I just want to point out a couple things. The first thing is that if the question had asked us to construct the, let's say instead of 95%, we'd been asked to construct the 90% confidence interval estimate, the only thing that would be different in that case is that the multiplier here would change, okay, and it would become 1.645. And let's suppose instead we'd been asked to find the 99% confidence interval. Then instead of having a 2 or a 1.645, we would use 2.576 as the multiplier. And that would be the only thing that would be different. The very last thing I want to point out is, if you're not able to enter this whole expression into your calculator, you can round at some of the intermediate steps, but just make sure to be very careful and use, 6 decimal places or more, or just use sufficiently many decimal places. So, for example, if I had to enter this into my calculator before I did took the square root, I would want to make sure to go out quite a few decimal places. So, for example, I could enter this number and then enter that under the square root, and that would give me, that would allow me to estimate this expression. So let me just write out what I would have. So the square root of 0.000210 is about, so I went out about 6 decimal places. And if I use these rounded numbers, I get, and then rounding the final answer, I get 0.651 and 0.709. So if I'm very careful, I can get a final answer that's close to the accurate answer.